So let's spend some time talking about absolute value equations. Now, before we even get into the equation part of it, let's do a little bit of a reminder to ourselves, and that is, what is absolute value? Remember, absolute value is a distance. Okay, when I ask you what's the absolute value of 12, I'm asking you what is the distance from 12 back to 0 along a number line. Well, that's easy. 12 is 12 spaces away from 0. But that's also why we do absolute value of -6. Well, the absolute value of -6 is 6 spaces, so the absolute value of -6 is 6. So when we talk about a problem like this, it says the absolute value of what is 12, I'm asking you what numbers are 12 spots away from 0. Well, again, that's, as we just got done talking about, that's two numbers. There's the number 12, but then there's also that number on the other side of the 0 on the number line, and that would be -12. Similarly, if I said, what's the absolute value of x is equal to 3? So in other words, what number has a distance of 3 back to 0? Well, that would be 3, or it would be -3. One of those two would satisfy that, or even both of them. So if we take that idea, we can go about solving absolute value equations. For instance, if I were to take, let's say, this first example, it says the absolute value of x plus 2 equals 8. Well, in order to solve absolute value equations, the first rule you need to follow is to get the absolute value all by itself. So that's what we're going to do. So we're going to subtract 2, and we get absolute value of x is equal to 6. So in other words, what number or numbers have a distance of 6 back to 0? Well, that is x is equal to 6 or -6. They both have a distance back to 0 of 6. So, not terribly difficult so far, but it does get a little more challenging. For instance, like this second example here. You notice here that this is not just asking the absolute value of x, but in this time it's asking for the absolute value of x plus 2. So, we got to have a strategy to come up with that. Now, if you notice all these examples that we did before, okay, we were coming up with two results, because when we talk about a distance back to 0, there's always two numbers. There's one number on the right hand of 0 on the number line, and there's a number on the left hand of 0 on the number line. And so to come up with both those answers, okay, what we do is we come up with this fairly simple strategy, and that is we're going to take this x plus 2 and set it equal to 6. Simple as that. Okay, and that's going to represent, essentially, that's going to represent the number that is on the positive side. Okay, but then in order to get the negative side number, what we're going to do is we're going to take this part right here and we're going to negate it. Okay, so that's essentially accounting for the number that's on the left-hand side of the 0, or the negative number, if you will. And so we're going to subtract them. We're just going to solve both these things. So we're going to say x is equal to 4, or, now this one's going to take a little more effort. You got to distribute -x minus 2. I would add 2. So -x is equal to 8. And then divide by -1. So x is equal to -8. So our two answers are x is equal to 4 and -8. Okay, and if we, whoops, sorry, didn't mean to cut you off right there with the work. And so if we take a look at these numbers and plug them back into the original, 4 plus 2 is 6. The absolute value of 6 is 6. If I were to take -8, -8 plus 2 is -6. Absolute value of -6 is 6. So they both do work. And this idea of splitting this equation up into two parts is really important, because again, we're looking for two values. Okay, we're looking for one that essentially is representing the positive number, or the number to the right of 0, and then the number to the left. So let's take a look at this next one. Actually, you know what? We're going to skip. We're going to come over here to number 4, and we'll go back to number 3 here in just a second. So here's our problem. Absolute value of 2x plus 3 equals 21. So we're going to take that first step, and that is get the absolute value by itself first. So I'm going to subtract 3. Okay, now notice I'm not splitting it up yet. You don't split it up until you get the absolute value all by itself. So now the absolute value is all by itself. So now I'm going to split it up. So now it's going to be 2x equals 18. or now I'm going to negate whatever's inside the absolute value, so I get that. Solve x is equal to 9, or over here this is the same thing as negative 2x, so I'd divide by negative 2, and so I get x equals negative 9. So x is equal to 9 or negative 9. Okay, hopefully that makes sense so far. So let's look at one last one. Now we skipped over 3, and we did that for a reason. So let's take a look. So we're going to get the absolute value all by itself again. So I'm going to add 5. So I get 3, the absolute value of x equals 6. I'm going to then divide by 3. So the absolute value of x equals 2. And so now we get to the point where we're going to split it up. So we're going to go x is equal to 2, or x is equal to negative 2. Or you can just write it as 2 or negative 2. And there you go. You know, the only reason why I skipped it is just simply because it took a little bit more effort to get that absolute value by itself. But again, the key is, before you do anything, before you do any splitting, okay, like we did on this one, or on this one, you have to get the absolute value by itself before you do any sort of splitting up. Okay, that's really important. Okay, other than that, it's just a matter of solving two different equations. And that's absolute value equations.